Hey class, I'm Mr Thornton and I'm going to help you get that C in your GCSE. This lesson, half-life. This topic was suggested by Yusuf Bilal. If you've got a topic which you'd like me to cover, just leave a comment below. Now, half-life in physics, when we're talking about nuclear radiation, is another one of those concepts which initially seems quite intimidating, but the principles behind it are really very simple. The underlying principle is that the rate at which any sample of radioactive material decays, that is the rate at which it breaks down into smaller, simpler atoms and gives out radiation, is constant. It doesn't matter how much of that sample you've got, the rate at which it's breaking down and decaying is always the same. So it always takes the same amount of time for half of the atoms to break down. That's all that half-life is. Let me try and explain in a little more detail. Imagine you had 1,000,000 radioactive atoms and they were breaking down and decaying by releasing alpha and beta particles from their nuclei. Over time, you're going to have less and less and less of them. And eventually, you're only going to have half of them left. The amount of time it's taken for that number of atoms to drop to half, that is the half-life. Where it gets interesting is it doesn't matter how many atoms you start with. You could start with 1,000,000 or 100,000,000 or 1,000,000,000 and the half-life will still be the same. If you've got lots and lots of atoms, they'll break down really quickly at first and they'll give out an awful lot of radiation. If you've just got a small number of atoms, then they'll only break down relatively slowly at first. So your half-life is always the same. Try not to worry about the mechanics behind this too much. Instead, think about it like this. You've only got one thing to remember now. That half-life is always the same. Now, of course, it's a bit difficult to count the exact number of atoms in a sample and how many are one type of atom and how many have decayed into another type of atom. But the other thing that we can do is detect how much radiation it's giving out, how active it is, or how radioactive it is, I suppose. We could measure the activity of this sample with a Geiger counter, which just counts how many of those radioactive particles are emitted. And let's say our sample was giving out 100 counts every minute. After one half-life, that number would have halved. It would be giving out 50 counts instead. Again, it doesn't matter what number we started with. If the first number that we got was that it was giving out 200 counts per minute, then the second number after one half-life would be down to 100 counts per minute. So basically your half-life is just how long it takes for whatever number you start with to drop to half of what it was. We call this exponential decay. If we started with a count rate of 200 after one half-life, it would have halved to 100. After another half-life, it would have halved again to 50. After another half-life, it would have halved again to 25. After another half-life, it would have halved again to 12.5, and so on. So whatever number you start with, after one half-life, it would have halved. And they could get you to do something similar to this in the exam. They could give you a number and say, after 3 half-lives, what will this number have fallen to? And so you halve it, and then you halve it again, and then you halve it again. So just divide by 2 and divide by 2 and divide by 2 again on your calculator. Be aware that they could tell you what the half-life is, let's say 1 hour, and then they could say what will the number have dropped to after 3 hours. So after 3 hours you've had a half-life, so you've halved it, and then you've halved it again for 2 hours, and then you've halved it again for that 3 hours. So try and stay aware of that. The only other thing which they might try and get you to do with half-life is to figure out the half-life from a graph of either the number of nuclei remaining or the count rate. And the graph will always have this sort of shape. This is an exponential decay curve, and it's really important that it's got that sort of shape because that represents our number halving and halving and halving again. And it will always be this shape. It doesn't matter what number you start with, you always get this shape of graph. And all you've got to do is find out what your start number is, halve it, and then find out how long on this bottom axis here it's taken for that number to halve. So again, find your first number, whatever you start with, up on that vertical axis just there, halve it, and then find out how long it's taken for that number to halve. Okay, you just draw your line across and down, and you should get your answer. Let's take a look at one more example to see how that works. Here my initial number of nuclei was 512 billion nuclei. So what I need to do is calculate half of that for a start, And so when I work that out on my calculator, half of 512 billion is 256 billion. So then I find where 256 billion is on my vertical axis. I draw a line across to the line on the graph, and then I draw a line straight down and I see what number I've got on that time axis. That gives me my half-life. In this example, you can see that the half-life is 200 years. But the really interesting thing about half-lives is that some of them can be incredibly short, less than a second, and some of them can be incredibly long, thousands of years. You get a huge range, so don't worry if you get a number when you're working out half-life which seems like either a very small or a very big number, because you do get a big range when you work these out. I hope that video really helps you. If you want to check how well you understood, then try the snap quiz. The link is right here, and it'll also be in the description along with all the other links for this video. If you want to check out my other videos, then click right here. If you want to download the free app I've made to help you with your revision, then you can click right here. If you want to subscribe to my channel, then you can click right here. Don't forget to leave likes, and if you go to the comments, you can give me feedback and let me know which topics you'd like me to cover next. Good luck in your GCSEs everyone, and thanks very much for watching.